Lecture 6, Neupulator Control. Today we will discuss shoulder control with accelerometer and elbow control with EMG. So after you create the new script, go to variables, make variable, and we'll name it shoulder pause, which stands for shoulder position. Now we will create a new variable named EMG. Next, drag the set variable 2 into the forever loop. We will change the value of EMG to shoulder position. Since we are using the accelerometer to define the shoulder position, we can go into inputs and drag acceleration block, change that to Z, and put it into the set shoulder position tool. Now let's go to the extensions and let's write the same URL we used in the past to include the library for the EMG. You can copy and paste the URL from the PowerPoint presentations or just write it as shown. Then we click on EMG filter and then we go to the custom tab. Then select the function that reads set PO servo and drag that under the set shoulder position tool. Finally, go to variables and select shoulder position and put it right after direction. Then change the by 0 milliseconds for a 2. Now looking at the hardware side of things, we gotta make all the connections. This is assuming you already have built the Neupulator arm. So first, having our battery pack, let's connect the ground on the blue vertical line across the breadboard and connect the red on an arbitrary space on the breadboard that is not connected to the breakout pins. To connect the shoulder motor to the breadboard, we need 3 male-to-male cables that go from the motor connection to the breadboard. Remember, we have a positive, a ground, and a signal cable. First, connect the ground to the common ground, which is the same ground as the microbit and the battery pack. Then, connect the positive cable from the motor to the same node as the positive cable from the battery pack. Finally, they connect the motor signal wire to the terminal P0. Now, we can turn on the battery pack and watch out! We see that the shoulder motor moved, and we can use the microbit with the accelerometer to control which way we want the shoulder position to move. Think, how is this useful? How can someone with impaired mobility use this type of system to extend their range of motion? Part 2, EMG for elbow control. Connect EMG hardware as shown in lesson 3. As you can notice, I have placed a book on top of the Neupulator base to prevent it from swinging too hard and falling down. Now, we will connect the shoulder motor to the microbit and the breadboard. For this, we need 3 male-to-male wires similar to the previous motor. We still have one positive, one ground, and one signal cable. The only difference is where we're going to connect that signal cable. So for this experiment, we will connect the signal cable on P1. We also have our positive wire and the common ground. It's time to code a way to measure the EMG signal and relate that to motor movement. Well, we have our set EMG variable to 0, and we also have the filtered EMG variable. The plot function will help us understand what is the range being measured by the EMG sensor. Also, of course, we want to plot the EMG variable and plot it up to 1023. Now, we need to use the map function. We can find it in the search bar, and we can drag and drop to store it while we look for the set EMG variable 2. We put the map into the 0 of 2. Finally, we need to let it know what variable we're going to be mapping, and of course that's going to be EMG. So for our low and high value, we need to look at the show data device plot and see what is the range of our muscle activation being picked up by the EMG sensor. We can see a baseline value of 87, but when I contract my muscles, we see a peak value of 450. So we can use this range and put it into the map function. The too low and too high will indicate the range of the motor in degrees that is going to be associated with the minimum and maximum value of the EMG measurement. Then in the servo functions, we're going to be using set servo as a way to command the motor to move. Of course, it's going to move relative to the variable EMG, which has been defined again as the angle related to the EMG measurement. The following is a live demonstration of the EMG sensor being used to control the elbow motor. So we turn on the EMG sensor and the battery pack, and of course we can test again that the shoulder motor works. However, now we want to use our bicep muscle activation to control the elbow motion. So we can clearly see that when I move my arm or contract my muscle, the elbow motor also moves inward. Now we can combine the movement of the accelerometer and the EMG sensor to control the shoulder and elbow motors. That's all for this lesson. Great job!